Okay, we're going to try this again. Technology's not being my friend today, so hopefully that'll change. We're going to talk about solving quadratic equations by factoring. Y'all have all been factoring for a while, so hopefully this is a review, but we are putting it all together. If you have any questions about any specific problem, please come see me. It is important for you to be able to, for you to practice this um, so that you will be efficient at it in future years. Okay, let's pause for a moment. Okay, I'm taking my chances by trying again because we're in between classes, but I'm trying to get this done. So I'm going to move forward. So, first and foremost, the first step that you always want to do in factoring is as you all know, technology hadn't been my friend. The first thing you always want to do is look for a greatest common factor. So I have four terms here, and I notice that what is in every single one of those terms is a y. So when I factor out a y, I have x squared, and then I have bxy, and then I have minus cx, and then I have plus d squared y. Okay? So, if you have any questions about any of these techniques, please, please come see me. Okay, difference of two squares. A squared minus b squared is a minus b times a plus b. These two are called conjugates. Okay, now this next one might be new to y'all, the sum of two cubes or the difference of two cubes. And some people like to refer to this one as okay. Don't listen to them. Try to listen to me. And this is what is referred to as SOAP. Some people do, and I'll tell you what that means in just a second. But how this factors is a plus b. You're just taking the cube root of both of those with the plus sign. Then you square the first term. I'm looking at this one right here now. Square the first term, change the sign, multiply them together, and square the last term. Okay? What's different if it's a minus b, a cubed minus b cubed, is this sign right here. So it's a minus b. Again, working from that factored. You square the first term, change the sign, multiply them together, oops, and square the last term. Now, where does SOAP come in, you might ask? Well, some people refer to this, or they say that this sign is always the same as what you start with. This sign is always opposite, and this side is always positive. So SOAP is basically telling you what the signs are doing. But you still got to know the factored part. Okay, a PST, I like to call them PSTs because perfect square trinomial is a lot to say. But you're recognizing that this is a perfect square, that is a perfect square, and when you take the square root of those and multiply by 2, you have your middle term. So how does that factor? It is a plus or minus b quantity squared. And now hopefully you realize if it's plus over here, it's plus over there. If it's minus over here, it's minus over there. And that's what that means. Okay, general trinomials. There are so many different methods out there. You need to pick whichever one that you are efficient and accurate in and go with that. Okay? And the last one that we have is grouping. And generally, the grouping is the first two and the last two. Sometimes it could be the first three and the last one, or the first one and the last three. But more often than not, it's the two and two. So you're looking at those two terms together and you're saying, what do they have in common? Which is an A, leaving me with x plus y. Always would take that sign of where you're dividing your groups. And then these have a common b, leaving me with x. Now you might think it's minus, but it's plus because I factored out a negative, so it changes that sign. And then hopefully you can see that this is a common term, leaving me with x plus y times a minus b. So this becomes that. That would be your final form of that factored term. Okay, so let's go do some problems all about factoring and know all the different things they're going to ask you. Write a quadratic equation in standard form with 3/4 and -5 as its roots. So we've talked about we had that chart yesterday where we went back and forth and what does it mean. So if these are my roots, then that technically means x equals 3/4 or x equals -5. And if I to get rid of this fraction here, that would give me 4x equals 3. And if I set it equal to 0, then I have 4x minus 3 equals 0. And over here, I'm going to have x plus 5 equals 0. And basically, those are my two factors that I'm going to go backwards with my zero product property. And now I would multiply those two factors together. They do want it in standard form, so we'll multiply that out. FOIL, 4x squared is my first terms. My outside is 20x minus 3x is plus 17x. And then my last terms give me minus 15. So this would be your answer in standard form. Now, I just referred to the standard product property because we were going backwards. Okay, so what does it say? If A times B equals 0, then you know that either A equals 0, B equals 0, or both of them equal 0. Fair enough. So that was kind of what I just did and showed you. And so now we know, but that's what we use to solve equations. So we were going backwards before. Now we're going to go solve. So in looking at this problem, I have two terms. The first thing I always want to do is look for a GCF, which in this case is 5x. What am I left with is 4x plus 3. And once I have it factored, then I would set each factor equal to 0. So I'm dividing by 5, gives me x equals 0, 4x equals -3, so the other one is -3/4. So those are my answers. Okay, what if we go to the next one? Again, two terms. The first thing I always want to look for is 4y, leaving me with y plus 4 equals 0. So setting each factor equal to 0, 4y equals 4, y plus 4 equals 0. I know a lot of y'all can do it from there, so I'm going to say y equals 0 or -4. All right, the last one. Again, two terms. I'm looking for the GCF. You always, always, always want to look at that GCF first. So I have 6a. Remember, it's the lowest. Excuse me, I didn't mean to write on that. The lower exponent, or the lowest if you have more than 2. 6a to the fourth, and what's left is a plus 3. Okay, from there, 6a to the fourth equals 0. A plus 3 equals 0. So a equals 0 or -3. And if you have any problems how I jumped there, I divided by 6, and then you take the fourth root, and the fourth root of 0 is still 0. So that's why we're good there. Okay, difference of two squares. That's my pattern that we had up there, which says a squared minus, actually we have two. We have perfect squares. Sorry, I didn't read that. Perfect squares and the difference of two squares. So let's talk about the difference here. The perfect squares are going to be a squared plus 2ab plus b squared, and that factors to a plus b quantity squared. And if I have a minus here, I have a minus there. So three terms factor to two terms. And on the other side, if I have the difference of two squares, that means I start with two terms and I actually end up with this. So very important that you can distinguish between the two. So we're looking at this first one, perfect square, perfect square. So I'm going to jump to the square root of that, which is 2x. Always takes the sign of that second term, the square root of that, quantity squared. And check it, 2x times 3 is 6, times 2 is 12. That's your middle term. So when I solve that and I take the square root of both sides, then 2x minus 3 equals 0. 2x equals 3, and of course x equals 3 halves. Okay, let's look at the next one. 8x squared minus 9 equals 0. So from here I can factor, and that gives me 9x plus 3. Oh, you know what I didn't do, y'all? Because y'all aren't here to tell me. What did I just tell you the first thing you're supposed to do? That is factor that GCF. So let's factor out the GCF of 9. Now, it's an equation, and especially because there's 0 over there, you can actually divide both sides by 9. In which case, that gives me 9x squared minus 1 equals 0. Because 0 divided by 9 is 9. Then, when I break it up my two terms, I have 3x plus 1, 3x minus 1 equals 0. And when I set both of those, x equals plus or minus 1 over 3. Okay, if I skip too many steps, y'all please let me know. Email me, comment to me, or come see me. Okay, last one. Again, GCF. I cannot divide by a variable ever, ever, ever when you have an equation because you might lose a root. So I'm going to go ahead and just factor this one out, which is 3a, leaving me with 2a minus 1. Okay, and setting each of those equal to 0. 3a equals 0. 2a minus 1 equals 0. So a equals 0 or 1/2. All right. So now let's go into our favorite part, which is factoring trinomials. Okay, and this is where there are lots of different methods, but to start off with, I'm going to do 4a up here. It's pretty simple if a is equal to 1. If a is equal to 1, okay, you're looking for the factors of 30, and it depends on this. It's plus. So I'm looking for the factors of 30 that add up to 11. Okay, that would be 5 and 6. Now, why did I make them both minus? Because if it's a sum, then your signs will be the same. And they always take the sign of that second term. So x minus 5, x minus 6 equals 0, which tells me that x equals 5 or 6. All right, let's go to 4b. 4b, again, a is equal to 1, but this time, notice this is a minus sign. So I'm looking for a difference with the factors of 21 that subtract to give me 4. So that, of course, is x minus 7 and x plus 3. The signs have to be different. I knew it was minus 7 because I have a minus 4. So negative 7 plus 3 is what's going to give me negative 4. So that gives me an answer of x equals 7 or negative 3. Okay, so those are the easy ones because a was equal to 1 on both of those. Now let's go talk about a not equal to 1. Here we have a 15, here we have negative 12. So in the 15, again, there are many different methods of doing it. If this is a 1, this one's going to be pretty straightforward. I'm still looking for a sum, and I'm looking at, you really have to think of what a times c is. In this case is 15. So you're looking at the factors of 15 that add up to 8. And that, of course, is 5 and 3. So this is going to be 5x minus 1, 3x minus 1. Okay? Now, y'all, if you have a question, please write it down next to it and ask me the next time you see it. I'm not sure how much you know about factoring and how much review you need. So that's what I have, and that, of course, gives me an answer of x equals 1/5 or 1/3. Okay, the last one, let's go with 4D. Um, First and foremost, I'm going to multiply everything by negative 1 because I don't do well when my a is positive. So that changes the sign of everything. So my polynomial is going to be 12x squared minus 8x minus 15, and 0 times negative 1 is 0. So you are multiplying these two together to figure out um, what the factors are. So in this case, a times c is 180. And so I'm looking for the factors of 180 that subtract to give me 8. Well, y'all probably already figured it out that that, of course, is 10 and 18. Okay? I can do this by grouping. I can do it by the ratio. Um, I will tell you this. What I do, what I've done before, is I write it in a ratio with my a term. Okay? A is equal to 12. So what I write is 12 to 10 and 12 to 18. And then if I can reduce those, okay, this has a common factor of 2, and this has a common factor of 6, which is going to give me 2 and 3. The other thing, minus 8 means I need this one to be negative, so I should put a negative with that. Okay, that is what how my quadratic factors. So I'm going to have 6x plus 5 and 2x minus 3. It is so important for you to check this because if you don't write the polynomial correctly, if you didn't reduce, you would have 12x plus 10 and 12x minus 18. Well, 12 times 12 is not 12. So that's a clue that you didn't reduce your factors as you should have. Of course, my life would have been a lot easier if I'd remembered to do the GCF. Oh, there's not a GCF. Good. That's a moot point. All right. So each time, of course, setting each factor equal to 0 gives me an answer of x equals negative 5 over 6 or positive 3 over 2. Okay. So one real word problem, and then I put some cubes from a worksheet at the bottom of this. See it right here? And I will go do some of those just to make sure you have some examples because they weren't in our book, and I know you need to be responsible for that. So, Juan, excuse me, not John, recorded his brother bungee jumping from a height of 1,100 feet. At the time the cord lifted his brother back up, he was 76 feet above the ground. If Juan started recording as soon as his brother fell, how much time elapsed when the cord snapped back? So we're going to use this equation where c is the height in feet. And so I have this equation, f of t equals negative 16t squared plus c. So what I'm trying to find out is, I don't know what c is, but the cord lifted his brother back up. He was 76 feet above the ground. So that means that 1100 minus my 76 is that height that I'm looking at. Okay? Um, so that means that's what I'm going to plug in for my c. So f of t is equal to negative 16t squared plus 1024. So what are they asking me to find? How much time elapsed when the cord snapped back? Okay, um, and that cord snapped back, this is going to be 0, so that's going to give me 16t squared equal to 1024. T squared equals 1024 divided by 16, which is 64. So t equals plus or minus 8. So can't have negative time, so my answer is going to be 8 seconds. I'm trying to make the video quick, so if I went through that too quickly and you can't follow what I did, please come see me, ask me questions, email me questions. Okay, the last one we have for our factoring are our cubes. And remember on that first page, a cubed plus or minus b cubed. Okay, it's a plus b. I'm doing the first one. Oh, it's not. Oh, yeah, it is. A plus b because it's the same. Then you square it, change the sign, multiply them together, and always positive. So if it's minus, this is minus, and that's plus, and everything's the same. So on this particular problem, to factor it, the cube root of 8t cubed is 2t, same sign. Cube root of 27 would be 3w. So then I square the first term, change the sign, multiply them together, tw, and then square the last one. So that is how this factors. Now, that is the only way it factors. So if you had to solve that equation, this, of course, sets equal to 0 and easily, well, you have two variables, so that's not an issue here because we wouldn't. But if it was just one variable and you had to solve it, you're going to have to put it in the quadratic formula, okay? Because it does not factor. All right. So I'm going to do one more minus. I'm going to do this one. Um, Notice here, again, as we're always supposed to be looking for, it's that GCF. So when I take out a GCF here, I have 2x, which leaves me with x cubed minus 64. So my next step is 2x, cube root of x, cube root of 64. Then I square the first term, change the sign, multiply them together, and square the last term. So this is how it factors. All right, so you have some of those to practice. Answers are at the bottom. If you have any questions, please come see me.